If we see an ethyl alcohol, it has 6 hydrogens. So generally it will absorb at a particular wavelength. So we may think that all these hydrogens will absorb at a single wavelength, but this doesn't occur. The experiment resulted in giving 3 different peaks at a different wavelength. The question arises that why this particular ethyl alcohol gives 3 different peaks. The reason is the hydrogen which are present here has different environmental condition. Environmental effect is due to chemical shift and spin-spin splitting. So here we are going to discuss about chemical shift. With this chemical shift, what kind of differences can we see in NMR peaks? We studied a magnetic effect of electric current in our 11th or 12th standard. In that it says moving current produces a magnetic field around itself, which we call as induced magnetic field. A molecule can have bonded or non-bonded electrons. When a molecule is placed in a strong magnetic field, it produces a magnetic field around itself, and it is in such a way that it opposes the applied magnetic field. For example, we take an atom which has nucleus and electron, is kept in the applied magnetic field. So these electron revolves, and which produces an induced magnetic field which opposes the applied magnetic field. So the nucleus which experience the magnetic field will be less than that of the applied magnetic field. The applied magnetic field is H applied, and the nucleus which experience the magnetic field will be H naught. So H naught is equal to H applied minus H induced magnetic field. This induced magnetic field is directly proportional to the applied magnetic field. So we introduce a constant term which is called shielding constant. This shielding parameter is very important because for each and every kind of proton, this shielding parameter value will also differ because their environment is different. This shielding parameter value depends on electron density. As the electron density increases, that much of electron will rotate, and the magnetic field produced will be greater. So thus the shielding also. In between any two atom, there is a bond. So the electron density in each bond is not same. Difference in electron density can be due to inductive effect or resonance effect, mesomeric effect. In the bond between HF and HCl, the electron density on fluorine and chlorine will be different. So thus the sigma value, that is shielding parameter. So the nucleus experiencing magnetic field will also be different. From sigma value, we can predict that which functional group would have present in that particular position. Sigma is shielding, so here we are protecting a particular nucleus or we are shielding a particular nucleus from the applied magnetic field. In the example which we have taken, that is ethyl alcohol, the CH2 hydrogen are attached to the carbon, which will have different sigma value, and the CH3 which has different environment also have some other sigma value, and also the OH bond which is the hydrogen is attached to electronegative atom. So here the sigma value will be different. All these 3 sigma values are different. Here the sigma value for CH3 is greater than CH2 than OH minus, such that the hydrogens in CH3 is more shielded compared with the remaining two. So to make the CH3 and CH2 protons to resonate, more magnetic strength needs to be applied than the expected field strength. This is due to the shielding of those protons.